The area under a curve then, chapter 8. Here's a picture of a curve, y equals f of x. We're going to look at f of x positive in the first instance. So this is the curve, y equals f of x. Now, the area of the segment from here to here under the curve then, we can think of it as a summation of these rectangular strips of height y, because it's on the curve of height y, and thickness delta x. So that's the area of the strip. Sum, this is the symbol for sum. It's a sigma symbol, capital S in Greek. So sum all these strips starting from x equals a to x equals b. And then the actual area, that's approximately. But in the limit that delta x these strips get thinner and thinner and thinner, then this summation of all these horizontal strips will tend to the value of this, which is the integral. This is a s, so it means the sum, which is the integral symbol between a and b of y dx. So that's all it is. The area is just the integral. So look at some examples then. Here we got a curve y equals x squared. We want to find the area between 1 and 3. So we need to sum the strips between 1 and 3. And the y values is x squared times delta x. Of course, that's the area, sum the strips, height and width. So integrate that as x cubed over 3 between 3 and 1, which is top value, over 3, take away bottom value, over 3. And then when we tap that in the calculator, this is 27 over 3, this is 1 over 3, so we end up with 26 over 3. Okay, let's have a look at this next problem. I'll do a tiny sketch of it here. Sine 2x from 0 to pi over 2. It's going to look something like this, I think. Because when x is, we get sine pi. So pi over 2 is here. Sine pi is 0. Sine 0 is 0. And this is the curve sine 2x then. X-axis 0, y-axis. So the area then, we'll call it A, is equal to the integral between 0 and pi over 2 of sine 2x dx. The integral of sine is minus cos 2x, but it's cos ax over a. The a is 2. So that's the integral, standard integral, between 0 and pi over 2. So that's equal to then, let's just give ourselves a bit more room. I'll move this across. Over here. So that's equal to, it would be minus a half. Cosine of 2 pi over 2 is pi. Minus, that's the top value. The bottom value is minus a half cosine 0. Which equals, cos pi is minus 1, so this is minus 1 times minus half is a half. And take away, cos 0 is 1, take away minus a half, so that becomes plus a half, doesn't it? So it's equal to 1 square unit. And that's the area there. Next example. Okay, let's have a look now when f of x is always negative then. See, it's under the curve. These strips now, width delta x, but the height y is negative. So this integral will turn out to be negative because all these strips have negative heights. So when you times these, you'll get a negative. So the area needs to be flipped to being positive because area is always positive. So let's have a look at an example of that. I'll draw a quick sketch of this. X squared minus 10 between 1 to 3. The curve's going to look something like this, isn't it? Because it's a quadratic. Oops. I'll try and draw it a bit better than that. So it's a quadratic curve. Comes round and up. Is the x, y, and 0. This is the value minus 10. When x is 1, will be here at minus 9 on the y heights. And x is 3 is here. So this is the area then. It's always under the x-axis, so it's negative. So we use the formula above, minus the integral between 1 and 3 of the x squared minus 10 dx. So that's equal to, integrate x cubed over 3 minus 10x is the integral. Evaluate that between 1 and 3, and don't forget it's a minus. Minus, top value, take bottom value, put 3 in, 27 over 3, which is 9, minus 30, 10 3s are 30, and this one, put 1 in, 1 cubed over 3 is 1/3, minus 10 times 1. Okay, what do we get? We get minus bracket minus 21 on the first. This is plus 10 minus 1/3, plus 10 minus 1/3. So we get, run the minus through all this, minus 11 that will be, won't it? So it'll be 11. So that's minus 11, and that's minus 1/3. So it ends up being, when you run the minus through, plus 11 plus 1/3, which is 11 1/3. That's the answer. So we get 11 1/3. Okay, question 4. Just question 4 now. Let's have a look at this one. Okay. Question 4. Area between y equals minus 1 over x, the x-axis from x equals 1 to 2. Let's do a quick sketch to see if it's positive or negative. Minus 1 over x. Well, 1 over x looks like that. So minus 1 over x will look like that. From x equals 1 to 2. So there's a quick sketch just to see what we've got. So we can see it's a negative area. So here the area A then is equal to minus the integral from 1 to 2 of the y value dx. Run this minus through, we end up with simply 1 to 2 of 1 over x dx. This is log x. When you integrate it, between 2 and 1, top value take bottom, log 2 minus log 1. This is 0, so it just ends up with log 2, which you can calculate to so many degrees of accuracy, approximately equal to 0.693 if you tap it in the calculator. Okay, let's have a look what happens to the area when f of x is positive and negative. An example is illustrated here. If we want to find the area between the curve f of x and the x-axis, between a and b, there's the y-axis over here, isn't it? If we want to find out that area then, between a and b, okay, well it would be this area here, wouldn't it? Bounded between the curve and the axes would be here, this segment and this segment. That's where it crosses the axis. So this area would be the positive strips summed, which would correspond to this one. And then here's all the negatives. So you'd have to put a minus in front of this second segment from C through to B and sum that integral. And when you add them together, you'll get the total area. So you have to take into account whether it's positive or negative and divide the integral up accordingly. So here's cosine x. It goes like that, doesn't it? Like that. This is pi over 2. It comes back to 0 at pi, the cosine function, but we're just short of that of 5 pi over 6. So it's positive here from 0 to pi over 2, and then it's negative from pi over 2 to 5 pi over 6. So the area then, bounded by the curve in the x-axis, this is A1, this is A2. So we could write A1 plus A2, which is equal to, the first area is integral y dx between 0 and pi over 2. The second is negative, so we need a minus to take account of that so that we can flip it to positive. From pi over 2 to 5 pi over 6 of y dx. So that's equal to then integral of cos between 0 and pi over 2 minus the integral of cos between pi over 2 and 5 pi over 6. Okay, so what do we get? We get the integral of cos is sine. So this first one is this definite integral. And evaluate that between that. And this one is sine again, of course. But that's between pi over 2 and 5 pi over 6. So what do we get? Top value sine of pi over 2 is 1. Minus bottom value sine 0 is 0. That's the first one. Minus the second one. Top value sine 5 pi over 6, which is sine 30. Pi over 6 is 30. Tap it in the calculator, you'll get a half. So we get a half. Take away sine pi over 2, which is 1. So that's what we get when you tap it in the calculator. So we get 1, take away minus a half. So it's 1 plus a half, isn't it? So 1.5 units squared would be the answer there. For example, 5. Okay, good. So let's move on to 6. Area of this. So I'll do a quick sketch here. Squeeze it in here. 12 minus 3x squared. So it's an N-shaped curve. Like so. Say. We're doing it between 0 and 3. There's the 3 value. There's the 0. When does this equal 0? Well, if we put x as 2 in, we'll get 4. 3 4s are 12. So it crosses here at 2, which we could work out. So we get this area here and this area here. A1, A2. So area, I'll try and do it quickly, is equal to the first area between 0 and 2 of 12 minus 3x squared dx minus the area from 2 to 3 of 12 minus 3x squared dx. So we get 12x minus 3x cubed over 3, which is x cubed, between 0 and 2 minus 12x minus x cubed between 2 and 3. To save time, I'm just going to write down the answer for that one, and I'll leave you to work it out. Minus, what do we get here for the area? We get 23. 16 plus 7 equals 23. I just want to finish by saying the area between two curves then. Here, you can see two curves here. These are y's, so the height here is a positive height. If we take that one, take the higher one, take the lower one. So area will be between where they cross here, A, where they cross here, B, and you take the difference, which is a positive height. So wherever this intersection is, the area between will always be fx minus g of x. So looking at this problem, try and do one of these. So I'll look at this one if I can quickly. Y equals 3 and y equals 4 minus x squared. 4 minus x squared, and y equals 3. When x is 1, we get 3, don't we? And when x is minus 1, minus 1, 1 are these 2 points here. So the area will be the top value, 4 minus x squared, take away the lower value, 3, dx between minus 1 and 1, which is 4x minus x cubed over 3 minus 3x. And work that out between 1 and minus 1. And in the notes it's done, and we get an number 7. It comes out at 4/3 when you work that out. Just a quick word on the last one, because we've got a few moments left. X squared minus 1, x plus 1. You've got a straight line here for x plus 1. X squared minus 1 would be a U-shaped curve, wouldn't it? Something like that, I think. When do they meet? They meet here, so you'd have to find when that equals that. From the sketch, it comes out at 2 and minus 1. Here, actually, this is the point where they meet at minus 1. So this would be the height there.